All right, everybody, here we go with mutations. Very exciting. All right, so a mutation is any change in the sequence of bases in DNA. It doesn't always have to have a harmful function. It can. Mutations are often harmful, but they're not always harmful. Some mutations have no effect whatsoever. Okay. And some mutations are actually beneficial. And we call this an adaptation. And we're going to talk about that a lot when we talk about evolution. Okay. Adaptation are advantageous mutations. So basically, mutations almost always happen during DNA replication. Okay. Or can happen during DNA replication. Accurate replication and proofreading is almost makes error-free DNA. Okay, so during replication, DNA polymerase basically makes an error about every 1,000 to 100,000 base pairs. So again, you have 3 billion. So that's a lot of errors, but it's going very fast. DNA polymerase goes very fast. So it's going to make some mistakes. Okay. Completed DNA strands only contain about one mistake every 100 million to 1 billion base pairs. So all of those, almost every one of these errors gets fixed. And that's because there's these great little DNA repair enzymes which proofread, okay? It's basically spell check for DNA, okay? And proofreading occurs both during and after replication. All right. So other things that can cause mutation: toxic chemicals, carcinogens, teratogens, radiation, obviously from like radioactive chemicals, but as well from the sun. The sun is your enemy. I mean, we love the sun, but there's my son with sunglasses again. Dude. Okay. So, and of course, errors in replication. So those are kind of the three main ways we get mutations in DNA. Okay. So mistakes can be made during normal DNA replication. Chemicals, components of cigarette smoke, for example, contain carcinogens that can mutate the DNA. Ultraviolet radiation and X-rays also contribute to mutations as well. All right, kinds of mutations. There are a couple of different kinds of mutations. The first kind we're going to look at is called a point mutation. Okay, also a nucleotide substitution where one base is changed to a different nucleotide. Okay, so one nucleotide is just changed to a different nucleotide. So instead of an A, it's a T. Insertion mutation is when you add a base pair to the DNA, or more than one. One or more new base pairs are added. And then there's deletion mutations, and hopefully you figure this out. One or more nucleotide pairs are removed or deleted from the DNA. Okay. There's also large scale mutations when large pieces of chromosomes are moved. An inversion occurs when a piece of DNA gets cut out, spun around, and inserted back into the same place. A translocation, you're moving your location, occurs when a chunk of DNA, again, often very big, is moved from one chromosome and attached to another. Okay. And remind me to tell you in class about how my son and daughter both have translocations. It's kind of cool. All right, so here's just some pictures that show you the different kinds. So nucleotide substitution, or a point mutation, okay, is where they basically just took this adenine here and replaced it with a thymine, and so the base pair got changed from an AT base pair to a TA base pair. This may not seem like it makes a significant difference, but it can. So that's a substitution. It's just change in a base pair, but it doesn't add or delete. An insertion is where we add a whole new base pair. So instead of this going here CTGA, it now goes CTTGA. Okay, and there's an extra base pair. So that's an insertion. A deletion is where we cut one out. So we've taken this CG and removed it. So it went TCCTG, and now it goes TCTG. Okay, so we've lost one. And then we have our big moves. An inversion is where we take a big chunk of a chromosome, spin it around, and put it back in. Okay, so you'll see if you look at this section here, with respect to where it is up here, it's basically flipped or inverted. It's almost like a mirror image. And then a translocation. Okay, and it doesn't always have to be a swap. So this chunk here broke off, and this chunk here broke off, and we moved this one up here, and this one down here, or down here. Okay, wait. This one up here, and this one down here. Oh, see, there's slightly different colors. This is a lighter color, and this is a darker color. Okay, perfect. But this can cause big time problems. Okay, so I think that's it for mutations. I hope you enjoyed our program today, and I will see you on the flip side.